That's right. Moles of what? Moles of what?
Anything.
Yes, moles of whatever you're talking about. Moles of the stuff that's dissolved in the other stuff, the solution, right? So, moles of material for every liter of what? Liter of solution. For a liter of solution. That's right. So, sit right, Brady. So, moles per liter is how you relate the concentration of some solution to somebody else. Alright? So here I have a solution. Here it is. Ta-da! It's in this bottle right here. See? And it says on the side it's 0.1 molar HC2H3O2. 0.1 molar HC2H3O2. So how many moles, and this is, let's say, a line right here says 1 liter. So how many moles are there? Let me check this thing really quick. How many moles of that stuff are there in that solution?
0.1.
0.1. That's right, 0.1. Okay? 0.1, because it says right here that it's 0.1 molar, and molar means what?
Per liters.
Moles per liter. Are you guys okay with that? Does that make sense? Is molarity easy for you guys? Good. Wonderful. Okay? Moles per liter. 0.1 molar. That means 0.1 moles for every liter because I had a liter. If I only had, let's say, this was only down to here, and say like that is 0.75 liters,
It would be different.
it would be different. How many moles of HC2H3O2, acetic acid, how many moles of HC2H3O2 do I have?
100 divided by 75.
Okay, so here's what we would do.
Wait. So when it says 0.1 molar, does that mean per liter or for what's in there?
Per liter, because big M means moles per liter. That's concentration. If I have my vinegar, where did my vinegar go? Did we put it away?
Yeah.
Here's a solution. All right, the solution is 1 molar sodium chloride. Okay, I've dissolved 1 mole of sodium chloride per liter. That's the concentration here. Now, what's the concentration of the water in my hand? Salty water. What's the concentration of the water here compared to the water here? It's the same. Concentration tells you how many moles there are per liter of stuff. If I say here I have a mole of sodium chloride and then I put some in my hand, how many moles do I have here? Is that the same?
No.
No, that's not the same. Because moles, it's like saying this is, let's say I have it here, not sodium chloride actually. You want to taste it, Tim? You want to taste my salty water? Let everybody know how salty it is after you taste it.
Really?
Ah, is that horrible? Want to taste it, Brady? Oh, tell everybody how salty it is. You want to taste some?
Ah.
Tell everybody how salty it is. Is it horrible salty? Okay.
Yep.
Is it salty, Tim?
Yeah.
No, it's not salty.
I know, it's just water.
Okay. So, but let's pretend that I have something else dissolved in here. Let's say it's dogs, okay? Because we can think better about dogs. They're big things. Maybe they're a little bit small. Depends on the size of your dog. But let's say I have 5 dogs for every cup of water here. 5 dogs. So this is a cup of water. So how many dogs do I have in here? 5 dogs. 5 dogs. So if I go like this and I put a little bit of water in my hand, do I have 5 dogs in here?
No.
No.
You probably have like
A quarter of a
half
dog.
a dog or something.
Yeah, 1/10 of a dog. So, but what's the concentration of dogs in my hand?
5 dogs.
for every cup of water, I'm going to have 5 dogs. So that's still the concentration. Concentration doesn't change by depending on how much you have. So when I brought the volume down, it doesn't change its concentration. It does change how many moles I actually have. Question?
Wouldn't the concentration be different if the two chemicals didn't mix together?
Didn't mix together? Yeah, if chemistry occurs, concentrations change. If you add more water. I heard a dog. Did you guys hear a dog? Concentrations change if you add other things, mix things together, that's for sure. All right, now, let's answer this question. How many moles do I have now in this container? How many moles do I have? How do I answer this question? No, we don't think that way. You can't think that way, because if you think that way, then when the problem gets too hard to know the answer to, you don't know what to do. Does that make sense? So you approach it with a method. What's the method?
Equal
You
sign.
write an equal sign. That's right. And then a blowout. And then make a line. What goes to the right of the equal sign?
Moles per
Moles per liter.
How do you know? How do you know what you're looking for?
Because it gives it to you.
That's the question is asking you. What is the question?
Moles of HC2H3O2.
Okay, so it wasn't moles per liter. It was just moles of HC2H3O2. Agreed?
Yes.
Scoot over, gentle people. So what do we start with?
0.1 moles of HC2.
That's right, 0.1. That is in units of moles per what?
Liter.
For every 1 liter. Right? It's moles of that stuff per liter. And now,
Oh, wait, liters are in the cup.
yes, I have to get rid of liters, don't I? Because I want to end in just moles. Correct?
Yeah, but we don't know how many liters are in that cup.
Yeah, we do. 0.75.
0.75 liters is how much I have in the cup. So look, that gets rid of liters, and now I'll be left in moles.
But that's not the right goal.
That is, that's the right number of moles that I'm going to have in that container.
0.
Divided.
Do what? 0.1 times 0.075. Right? In your calculator. Somebody, who can do it for me?
0.1.
All right. It's 0.075.
Wait,
Okay? Make sure you get that in your calculator.
isn't it just 0.75?
Yeah, it's only 0.7.
0.75 times 1 would be 0.75. But 0.75 times 0.1
Oh,
means it's 0.075.
Oh, yeah.
Okay? Make sure you get that in your calculators. Calculator. Fanatics. 0.1 times 0.75.
I can do that in my head. I have a calculator in my head.
And then divide that by 1.
What?
And also,
What do you got? What's your answer get?
Watch this.
0.75 times 0.1.
If it's working too hard, I also add a piece of paper and
Okay, gentle people. Now we need some utter strength. Can you dig down deep for this strength? I need your strength. Ready? Here's the question that I want you to be able to answer. If I have
0 grams. I have 0 grams of chicken, right?
10 or 0.01 liters of a 0.8 molar solution of HC2H3O2.
What is HC2?
That's vinegar. That's vinegar. That's the acid that's in vinegar. So vinegar is a 5% solution of this acid. It's called acetic acid.
Yeah.
If I have 0.01 liters of that molar solution of HC2, how many moles of HC2H3O2 do I have?
Equal sign.
Very good. Who
Equal
said it?
sign.
Equal sign. Very good. Blow out. Beautiful noises. All right. Now, consult with your friends. Consult with your friends. What goes to the right here?
Moles of
What do we start with? And then what are we going to do to get there? Consult with your friends. I'm going to go away for a moment.
Then we're going to start with the line and say 0.01 liters.
Consult with your
And
friends.
then we're going to say 0.8 moles of HC2H3O2. And then on the bottom, yeah, on the bottom one. Moles of HC2. Oh wait, I don't know. No, 0.8 and solution goes on the bottom, and then we need to
Who
get
needs a paper to think? Anybody?
I do.
I need paper and I think.
I need
how many
paper
moles
back.
of, and then we're already in moles. What? And then we're in moles. We're in 0.8 moles. We need to get rid of liters.
How do you work this thing?
Stuck together.
Oh no, you pushed the
Okay. Pen. Pen. Need a pen? Need a pen? You got it under control? Okay. Okay. What's your buddy say? What did your buddy say?
You have to
What goes to the right here? What did your buddy say?
moles of HC2H3O2.
I don't have the paper.
And we need the line.
I need a paper.
We already wrote
We
the
need
line.
this line there, you're right. You need a paper? Who's a piece of paper?
Oh, maybe.
Yeah, you don't need every single person. You can share if you want to.
3, 2, 1. Monty!
Here's a piece of paper.
He's going straight to them.
Special.
One more try.
Okay. What goes to the far left?
Moles of HC.
Why are you recording this?
We put them on YouTube.
0.8
This goes here to the.
liter.
That's right, 0.8. And what does that big M mean?
Molecular.
Molarity, which means what?
Which means,
Moles per liter.
Moles per liter. So, 0.8 moles for every one what?
liter.
Liter. All right. So, what's next?
We have to put liters now.
Okay, how many liters?
0.01 liters.
0.01 liters.
That cancels out.
And that cancels out liters, yeah.
All right, and then we're left with our moles of stuff. Correct?
But don't we need something under it? No. Or is that just for one, something else to do it?
You don't need to. I mean, what this is saying is that how many liters I have for every bottle. This will tell you how many moles you have in that bottle or whatever.
0.8 times.
No.
That's right.
Can I see your calculator real quick?
Okay? All right.
So 0.1 times.
If I have 0.1 liters of 0.8 molar
They're all
solution of H2O,
Even me? Going like this?
no. If I have
You're not in the shot.
If I want 0.07 moles of HC2H3O2 from a 0.8 molar solution of that stuff, how many liters do I need? Here's another one. If I want 0.7 moles of this stuff from a 0.8 molar solution of that stuff, how many liters of the stuff do I need?
But how many liters are in each stuff?
0.8 moles per liter,
Moles per liter.
right? That's
So,
what molarity means.
but you want 0.8 moles.
If I want that many moles of the stuff, and this is the stuff, this is the concentration of the stuff, how many liters do I need?
You need point.
You need to approach it the same way, right?
Equal sign.
So equal sign, breathe out. What goes to the right here?
Mole.
Oh,
Liters.
0.7.
What goes to the right, sweet Joe?
Liters of HC2, H3O2.
That's right, liters of my solution, right? Liters of HC2H3O2.
Yeah, it is.
Okay, that's the same. That's what I'm talking about. Liters of the solution of this stuff. What goes to the far left?
0.7. No, 0.8.
0.07 moles of HC2O3.
Okay. 0.07 moles of the stuff. That's how much I want, right?
Yeah. So then you would have to put
0.8.
But then you have to put 1 liter at the bottom, right? Yeah.
That's for liters.
Yeah.
And then you would put 0.8 molecular, right?
What has to go down here? Moles.
Moles.
Where are we going to get moles from?
0.8 moles.
That's right. 0.8 moles for every what?
1 liter.
For every 1 liter. Does that make sense?
Yes.
So I can identify how many liters I need by taking the moles and dividing it by the molarity. Right? So we answered 2 different kinds of questions here, didn't we? Both times we had to use the molarity, but sometimes the molarity had to be switched upside down, right?
Yes.
So to answer this question, what would we put in our calculator?
0.07 times 1 divided by 0.8.
That's right. All right? For those of you who have calculators, that'll be your ticket out the door. Everybody else, get out of here. We're late.